Now, when it comes to energy being changed from one form to another, a term we use often when describing this is efficiency. And it just describes how good a transducer is at turning a particular type of input energy into the useful output energy that we want. Now, a transducer is just any device that changes energy from one form into another. This can best be shown through some examples. So, for instance, speaker is 80% efficient. What do we mean by that? Well, a speaker is a transducer that tries to change electrical energy into sound. Now, no transducer is 100% efficient, but what that means is if I have a speaker and I put in 100 joules of electrical energy, it is 80% efficient, so only 80% of that, which would be 80 joules, nice round numbers here, will be converted into sound energy, which means really 20% of the energy we put in is lost to other things, which are usually heat and sound, but in this case sound is useful, so we will lose 20 joules to heat. Okay, now there's a little equation that describes this, and it is that efficiency is equal to the useful energy we get out divided by the total energy that we put in. Now, efficiency can be written as a percentage or as a decimal. To change this equation into one that will work with percentages, we just have to multiply that side by 100 and it will give us an efficiency as a percentage. It's a simpler equation without that, so I would tend to work with decimals rather than percentages if I can when dealing with efficiencies. So let's look at some examples. So it says here, bulb converts 50 joules of electrical energy into 45 joules of light. What is the efficiency of the light bulb? So we are trying to find the efficiency. We're told that the 50 joules of electrical energy is put in, so that is our total input. And it converts it into 45 joules of light, which is our useful output energy. Now, there isn't really any symbols that we can use to shorten this down, so at least for the first time I write down the equation, I would write it out in full. So we have efficiency equals the useful output energy divided by the total input energy. So I would then maybe shorten it after that is okay into 45 divided by 50. And when I do that, I get that it is 0.9 efficient. Now, if I wanted to represent that as a percentage, I just multiply by 100 here and multiply by 100 here, and that would give me that it's 90% efficient. Okay. Second example says a speaker is 75% efficient. How much electrical energy will be needed to produce 200 joules of sound energy? So we're told that the efficiency is equal to 75%. How much electrical energy? So it's looking for the input energy, which is what we're looking for, and the useful output is equal to 200 joules. And then we just put in our equation. So efficiency equals the useful output over the total input. And we then, well, I have a choice here. I can multiply this by 100 and put in my efficiency as a percentage, but I'd be more inclined, like I say, to work with decimals. I just divide that by 100 to give me 0.75, and then I end up with 0.75 equals the useful output, which is 200, divided by the total input, can't spell it, and total input, multiplied by the total input, equals 200, so therefore 200 divided by 0.75, and if you type that into your calculator, you will get 800 divided by 3 which is what, 267 joules.